So in rest, if a body does not change its position with respect to surrounding, then the body is said to be at rest. It is related term. How? Let's suppose we have a building. We have a building and a person is standing here. So if the person is not changing this position with respect to the building or with respect to the tree which is there, with respect to the another building, okay, so we are saying that the person is at rest. Okay, so this person is at rest. So similarly, when we talk about the motion, so if a body changes its position with respect to surrounding, then the body is said to be in motion. It is also a relative term. How? Let's suppose there is a building again, and there are also certain trees. If a person initially at this position on this road, after some time, if he moves and he changes its position from this point to this point, so he has changed their position. So then we can say that when he is moving, so person is in motion. Person is in motion. Okay, like there are many terms in which we can observe that, like a moving car. Moving car is in motion, but the garden or bus uh, the bus which is at rest or which is not moving, or the bus which is not moving is at rest. Okay, so in deciding rest or motion, we need an observer. In deciding that the body is in motion or at rest, in deciding that the body is in motion or rest, we need an observer. Let's suppose if the person is here and I am observing it here, so person is not moving, so this is observer. And similarly, I am here as an observer, so I can see that the person has moved from this place to this place, so the person is in motion. Okay, so there is a term that, is it actually the building or your school building is at rest? Your school building is at rest or in motion. Explain. Okay, let's suppose the school building is like a school building, it's a huge building. Okay, so and I'm observing the school building from the ground of the building. Okay, from the ground of the building, and I'm the observer. So I can say that the school building is at rest. Okay, but if I say the observer just go to the space and he is observing the earth from space. He is observing the earth from space. So um, so let's suppose there are certain point where the school building is there. So if I see that the earth is revolving around the sun, let's suppose here is sun. So the earth is revolving around the sun. So if earth is moving for this observer, so the things present on the earth is also moving. So school building is now in motion. School building is in motion. Okay, just I'm making the difference again. Like if we observe the school from the school ground, then we can observe that the building for this observer is at rest because building is not changing their position. But if the observer is in space and he is observing the earth, so the anything that is present on the earth, that is also moving because earth is revolving around the sun. So this school building will also change their position with respect to the sun. So at this time school building is changing their position with respect to initial position. Or the observer. So school building is in motion. Similarly, for the observer, the school building is not changing the position. So it is at rest. Now there is another topic that comes, it's a distance. Let's suppose a person is initially at point A, the person is here initially at point A and he started moving in this direction, and then he is moving in this direction, again he has changed and different path he has taken, and finally he has reached to point B. So we can say that if he has moved 5 meter, if he has moved 3 meter, 3 meter, 3 meter, 2 meter, 1 meter, 2 meter, and then finally 5 meter. From this point to this point he has moved 5 meter, then he has moved 3 meter, then he has moved 3 meter, 3 meter, 2 meter, 1 meter, 2 meter, and then 5 meter. So I can say that the person has covered the distance, and that has started from this point to almost this point. So distance is basically the total path length covered during motion is known as distance. So total distance for this case is 5 plus 3 plus 3 plus 3 plus 2 plus 1 plus 2 plus 5. So it is 5, 3, 8, 3, 11, 3, 14, 2, 16, 117, 2, 19 and 5, 24 meter. So total distance he has moved is 24 meter. 5, 3, 8, 8, 3, 11, 11, 3, 14, 2, 16, 1, 17, 2, 19 and 5, 24 meter. Let's take another example. A person is moving in a circular path of radius 7 meter. He completes 2 rounds. So after 2 rounds, how much distance he has moved? So at this point we can simply say that if there is a circle and the radius is 7 meters, so person has started moving from this point and he has moved 1 round and then another round. Okay, so we can say that in a circular path, if I am taking 1 round, so that is simply the perimeter of the circle. So distance moved in 1 round is equal to distance moved in 1 round is equal to perimeter or circumference of the circular path. So and the formula is 2 pi r. So 2 into 22 by 7 into 7. 7 cancel out and the distance in 1 round is 44 meter. So distance covered in 2 round is equal to 44 into 2, and that is 88 meter. Okay, now we are going to take another example. A person moves in a square path of side 14 meter. Find the distance covered in one round of the square path and 1.5 round of the square path. So this time the person is moving in a square path of distance 14 meter. So we know that square has all side is equal. So let's suppose the person has started, so he has moved this. He has moved then this and then this in one round. So distance moved in one round is equal to 4 into side. So that is 4 into 4, and that is 56 meter. So this is the first part, and then second part, distance moved in 1.5 round. So for one round that must be 56, and for half round it is like for one round the total distance and then half round. So he has moved this and this. So overall he has moved in one round. Distance moved in one round is equal to 4 into 14, that is 56 meter. And then he has moved this path. So this is 14 and 14. So in half round, half of the total path, or simply we can add 2 into 14, that is 28 meter. So after completing one round and then half round, so total distance after 1.5 round is equal to 56 plus 28, that is 84 meter. So in this way we find the distance. There is another question also. We will do that after one topic that generally comes. So there is a next topic is displacement. Next topic is displacement. So displacement is basically when we talk about the displacement, so we generally in daily life we say that just displace the object. So what we do, like if we have taken one key and we have displaced it from this position to this position, so we can simply say that key it has displaced from this position to this position. So we are indicating key at from this point. If we have displaced from this point, so we will simply say that we have displaced the key at this point. Or when we talk about the thing has displaced from one point to another point, so there is two fixed point in displacement. So we can simply say that this point to this point. So in displacement, the there must be two position, and that is like, if we have to measure the displacement, or simply we say that key displacement is, we don't say displacement is like this. We have displaced the key like this, and then it is placed here. We simply say that the key is displaced from this point to this point. So displacement is shortest path between two points, or initial and final point, is known as displacement. So in this situation we also say that the displacement has a fixed direction. Displacement has a fixed direction. This point to this point, there is a fixed direction. In which direction? In this direction. Okay. So how displacement applies in terms of distance also. Let's suppose we take the same example. In the circular path 7 meter, body's displacement after one round. Okay, so let the person is moving from this point to this point. So initial position and when he is completing one round, then it is same, this is also the final position. So if initial position and final position is same, then displacement will be 0. Like if I have taken the key from this point and I have moved it there, and then I put the key again at the same position, so is the key displaced? No, the key has not displaced. So total displacement in this case is 0. Similarly, the person is here and he has moved and reaches again at the same path, so is there any displacement in the position? No. Okay, so it is the same. So this is final. So if the initial position and final position is same, then displacement will be 0. Okay, then there is a term that comes speed. So what speed says, it is the ratio of distance to the time taken. So speed is simply that is equal to distance upon time taken, and it is also represented by v, and distance is represented by s, and time is represented by t. These are the symbols. One important thing, whenever we ask about the distance, so there is a term, there must be some symbol to represent it in the formula. Distance has symbol s, and there is unit, measuring unit, and that is meter. This is also SI unit. Similarly, in displacement, symbol is S and SI unit is meter. SI represents system of international and something like international system of unit. So if I take if I have to find out the unit of speed, so SI unit, and it is like the distance has unit meter and time has unit second, so meter per second. It is also known as meter per second. Let's suppose a person has moved 300 meter in 20 seconds, then find the speed. So here in this case the person has moved 300 meters, so this is 300 meter, and time is 20 seconds. So speed v is equal to s upon t. So simply 300 by 20, that is 15 meter per second. Similarly, a person is moving in a circular path of radius 14 meter. He completes one round in 8 seconds. Find the speed of the person. So again, the person is moving in a circular path and the radius is 14 meter. So distance moved in the one round. Distance moved in the one round, that is 2 pi r. Again, it's a circumference of the circle, so 2 into 22 by 7, and that is 14, so it's a 88 meter. Okay, so it's a 88 meter. Now if we have to find out the speed, so distance upon time, so it is 88 meter, and time is how much time he has taken? 8 seconds. So 8 11, so the speed is 11 meter per second. So in this way we find out the speed. Similarly, there is another term, velocity.